Hey everyone, let's continue on. We want to continue on in our discussion with vectors, but we really can't quite yet because we have to talk about determinants. And I put matrices up here because there's a relationship between the two. A matrix is an array, generally a rectangular array of numbers. And so I might have something like 5, -3, 2, 4, and I'll put it in parentheses, and that's a 2 by 2, 2 rows, 2 columns, a 2 by 2 array of numbers or arrangement of numbers. We call them arrays. This one's square because the width and the height are the same. The number of rows and the number of columns are the same. And when I say something like 2 by 2 or 3 by 5, the first number in there is the rows and the second number is the columns. Okay, so 2 rows, 2 columns in this case. Determinants are a similar sort of situation where you have an array of numbers, but instead of putting them inside of parentheses, we put them inside of vertical lines, like an absolute value sign. And a determinant always evaluates to some value, generally a single number. So in generally, well, let me start here. So with a 2 by 2, this is generally the smallest array or smallest determinant you're going to have. The way you evaluate that is you multiply, let me do this here, you multiply down and to the right and then up and to the right. And so what you do is you would take 5 times 4 and then you subtract, so the next number you subtract 2 times -3. Keep in mind I'm subtracting a negative number here. And so this will evaluate to 20 minus a -6, but minus a -6 is +6. So this determinant evaluates to 26. Now a determinant will always be square. 2 by 2, 3 by 3, 4 by 4. Technically, I guess you could have a 1 by 1, but that would just be the number, right? If I had a determinant that was 7, then that would just be 7. So we're never going to look at that. I've never seen one in all the years I've done that, so we're not going to worry about that at this point. A matrix can be rectangular, 3 by 5, 4 by 22, whatever, it doesn't matter. We'll talk more about matrices in another video. Okay, so a 2 by 2 determinant evaluates very straightforward. So if I put in A, B, C, D as a generic determinant, this would evaluate to A times D minus B times C. Okay, C times B, B times C. Remember, it's commutative, right? So this is just a number. This is just going to be a number, assuming A, B, C, and D are numbers. Right? If I had something like X, Y, 3, 7, this would evaluate to 7x minus 3y. Right? And that's how I would evaluate my determinant. Okay? All right. When the determinant becomes larger than 2 by 2, it becomes a little more complicated. I'm only going to go to 3 by 3, but let's take a look at how this is going to work. So imagine A, B, C. So I'm going to keep my numbers, or letters rather, for now. D, E, F, G, H, I. So imagine, if you will, that I have a 3 by 3 determinant. I want to evaluate it. The way this is going to work is you pick a row or a column. It doesn't matter which row, doesn't matter which column. And then you're going to look at what we call the minors of the elements in that row. So I'm going to keep life simple. I'm going to start off, I'm just going to take row 1. Right? I'm going to take row 1. So I'm going to have A, B, and C. And we're going to tackle these. Now when I take A, the way I find the minor is I take away the column and the row that A belongs to. Right? So the first column, first row. And if I wipe those out, right, if I take those away, I'm just left with E, F, H, I. So there's a determinant, EFHI, that is the minor of A. Right? That's what we call the minor of A. All right, so let me bring those back in. Maybe the whiteboard, I can erase it and then bring it back. The minor of B, I take out the column and the row that belongs to, and I'm left with D, F, G, I. So D, F, G, I is the minor of B. That is the minor of B. And then finally, we put those back in. Oops. If I go to the C that was up here, then I take out the row and the column that C was in, then I get D, E, G, H. D, E, G, H. And that's the minor of C. All right, so I've got 2 by 2s, and we know how to evaluate these 2 by 2s. We've done that. Then I'm going to combine these. Now, I'm going to combine them with addition and subtraction. And the way this works, when I take a 3 by 3 matrix, determinant, and any determinant, doesn't matter, of course, it's always square. The upper left is always positive, and then I alternate. So plus, minus, plus, minus, plus, minus, plus, minus, plus. Right? And it doesn't matter, I can go plus, minus, plus, minus, plus, minus. No matter how you go, you can't go diagonally, but left, right, up, down, you alternate pluses and minuses. And so what this means is, I'm going to add that, of course, it's the first part, right? So it doesn't matter. I'm going to subtract this, I'm going to add that. So this will evaluate to A times this determinant. Well, let's evaluate that determinant. It's EI minus FH. And then I multiply that by A. Subtract B times DI minus FG. Okay, D times I, F times G. Plus C times DH minus GE. And this is going to end up being a number, assuming all of these are numbers. Right? And then that'll evaluate out to some value. And that's how you do a 3 by 3 determinant, 2 by 2. All right? So, we'll pause for a second. Next video, I'll do a couple of different examples. The 3 by 3s tend to get messy. And in another video, I'll show you how to do them on your calculator. But we'll evaluate those and we'll see what kind of answers we get when we evaluate some numbers in here. And then we'll connect it to vectors. All right, there's a good start. Please let me know if you have any questions in the comments below. Thank you.